This lab in conceptual physics, we are going to use kinematics and an experimental setup in order to see how we can actually determine the acceleration due to gravity, that 9.81 meters per second squared that we've used so far in our free fall lesson. Okay? So the purpose is to determine the acceleration of gravity g by dropping a golf ball from a height of 2 meters. Again, we're looking at how we can apply kinematics to a real-world scenario to an actual lab setting. Okay? So here's a pre-lab question for you. Okay? We have 3 kinematic equations that we have worked with so far. However, there's only one kinematic equation that we're going to use to determine our acceleration due to gravity. So there's only one equation we're going to use for this lab, okay? So your goal here, all right, is to determine which of these equations to use, okay? So here's your scenario to help you narrow down which equation to use. Our golf ball is dropped from rest from an initial height h in meters and takes a time t in seconds, better said, in seconds to drop to the ground. H and T are knowns that will be measured during the lab, okay? So H is 2 meters, and then the T is what we're going to measure during the lab, okay? If we are looking for G as the object falls, which kinematic equation should be used to determine G? So please make sure you write out your knowns and unknowns, identify which equation to use, and then state a brief 1 to 2 sentence explanation for why you chose your equation. Next, you're going to have to determine which materials that you're going to need to use, okay? So this one is going to be more open-ended. I'm not going to give you materials. You'll have to determine yourself what materials we need to use, both materials listed in the prompt and materials that you may need to come up with on your own. And then down here, you're going to do a procedure and diagram. Okay, remember to be thorough. Avoid vague terms like it, those, and that. Remember, list units of measurements and be specific, okay? Make sure your diagram carries labels as well, okay? So this is the first page of your lab report right here, okay? So now in the data table, okay? In a data table, you have space for trials. In this spot right here is going to go the data that you're going to collect, okay? Which in this case, I'm going to let you determine what data we have to collect, okay? And then in this last column right here is going to be where you put your acceleration due to gravity for each trial. So what you're going to do is with the data you collect for each trial in the second column, you're going to use that to solve for and calculate your acceleration due to gravity for each trial, okay? And I leave you space for calculations in the space below, okay? And then what you're going to do is you're going to calculate the average acceleration due to gravity from all of your trials, okay? So for each trial that you get the acceleration of gravity for, you're going to take the average from all those trials to determine the data that you're going to report at the end of your lab report. So at the end of the lab report, you have 2 post-analysis questions based on your data and calculations. What is the experimentally determined acceleration of gravity? And then number 2, was one possible area that could affect your results, along with how, and a physically justified improvement to reduce the error. Okay? And this is your free fall lab.